Good afternoon, everyone. Welcome to a new session uh, of physics. Okay, so in last class, as we studied about functions, in this class we are going to study about straight lines. Okay, so as I discussed yesterday, that maths is very important. It will lay the foundation for you. Okay, in physics, if you know maths, okay, physics becomes very easy for you. Okay, so I Harish, okay, senior physics faculty, is going to teach you straight line today. Okay, so without wasting any time, let's start. So first, before starting straight line, let's talk about this. Okay, so coordinate geometry. So when I say coordinate geometry, what do I mean? So let's take an example. Let's suppose if I want to give location of any point on earth, okay, let's say this is earth, okay, and if I want to give a location, if I want to give my location, right, my exact location, so I can give my exact location by giving the latitude and longitude of my position, right? So latitude and longitude, so this is my longitude and this is my latitude. So the point, this point is latitude and longitude, right? So this point gives me the exact location. Similarly, in mathematics, okay, if I want to give the exact location of any point, I have defined a Cartesian system here. And in this Cartesian system, I have, let's suppose this is the origin. I have my x-axis and I have my y-axis. So let's define a point P. Let's say this point P is defined. So if I want to reach at this point, how can I reach at this point? I will have to walk, let's say if I walk x naught distance in this direction, x naught distance and y naught distance in vertical direction, I will reach at this point. Yes or no? So with respect to the origin, when I talk, I can say that the coordinate of the point P is x naught, y naught. So the location of any point on my Cartesian plane, this x and y axis together makes the Cartesian plane. In 3 dimension, if I want to address any point, I will address by giving 3 coordinates, that are x axis, y axis and z axis. So let's confine to only 2 dimensional for now. So in 2 dimension, I have my x axis and my y axis. And what's the most important thing about x axis and y axis? That they both are perpendicular. They both are inclined at 90 degree to each other. So now, if I want to locate this point P, I have to walk x naught distance in x direction and y naught distance in y direction. Similarly, if I want to locate some other point Q, I will have to walk x dash distance in x direction, and y dash distance in y direction. So I'll reach this point, right? So any point on this Cartesian plane, right? Any point on this Cartesian plane can be given by a set of coordinates, that is x coordinate and y coordinate. So basically this is my x coordinate, so this is my x coordinate and this is my y coordinate. Right? So now the summary is that if I want to locate any point on my Cartesian plane, okay, Cartesian plane, I will give a set of coordinates, that is x coordinate and y coordinate, and it is like a location, okay, location for that point. So now let's move on to the distance formula. So let's suppose I have this point P and this point Q. I have this P point and Q point, and I want to find the distance between both the points, right? So let's take an example. So let's say I am standing here, a person 1 is standing here, and a person 2 is standing here. So to find the distance between person 1 and person 2, you will draw a straight line and find the length of this line, correct? Similarly, I want to find the distance between point P and point Q, where P and Q are two different points on my Cartesian plane. So now to find the distance, what I have done, I have joined point P and point Q. Now if you look closely, this length y1 and this length y2, x2 are making the two sides of a right angle triangle, right? And this y2 length can be given by this length subtracting this length. And what is this length? This length is basically this length, right? And that is equal to y1. So can I say this whole length is equal to y1? Yes. Now, what is this length equal to? So this length is basically equal to this length, that is this length, and that is equal to y2. So if I want to find the perpendicular of my triangle, that will be equal to y2 minus y1. Similarly, if I look at the base, I can see that since this q coordinate, this q point has x coordinate is x2, so this is x2, so I can say that the length here is x2 here, so this length is x2. Now I want to subtract this length from x2 so that I can get this one. Now if you look at this point it is at a distance x1, right? So this length is x1. Now since this length is x1, can I say that this distance is x2 minus x1? So now let's draw this diagram. So if I draw this diagram, so I get a diagram like this, right? This length is y1 minus y2, this length is x2 minus x1, right? This length is x2 minus x1. Now if this angle is 90 degree and I want to find this length, what can I use? I can use Pythagoras theorem, right? Because this is the hypotenuse of my triangle. So let's apply Pythagoras theorem. So hypotenuse of my triangle. So this hypotenuse is equal to y2 minus y1 whole square, that is perpendicular square plus base square under root. So basically this is my distance formula. Okay, so to find the distance between any 2 points on my Cartesian plane, the formula is x1 minus x2 whole square plus y1 minus y2 whole square under root, that is difference of x coordinate square plus difference of y coordinate square whole under root. So now let's move forward. So now what do you mean by a polynomial? So a finite length expression of the form a0x0 plus a1x1 plus a2x2 plus I'll continue on to an minus 1 ax minus 1 plus an x raised to n is called polynomial in x of nth degree, right? So basically I was talking about functions the last day, and in the last class when I was talking about functions, what did I tell you? That it is kind of a function, right? In which I have, so this is basically y equals to, right? I can say this is equal to y, and for this I am giving input as x, the value of x I will give my input, right? And I will get output y, where a0, a1, a2 till an are constant values, okay, and x is my variable. So a polynomial is an expression with non-negative non-fraction powers. So if we talk about the powers, okay, they should be non-negative, means they should be greater than or equal to 0, and non-fraction powers, so they cannot also be fraction values, there cannot be any fraction values. So what are the values the power can have? They can have 0, 1, 2, 3, 4 and so on. So all positive integers are possible. So I hope the definition of polynomial is clear to you. Now you may think that why all of a sudden we are discussing about polynomials. We want to study about straight lines. So let's look at this closely. So if in this polynomial, let's write this polynomial here, right? So a0 x0 plus a1 x1 plus a2 x2 and so on. Now for what I will do, I will substitute all the coefficients, okay. So these are known as coefficients. So now let's put a2 equals to a3 equals to a4 and so on till an, all equal to 0 except a0 and a1. Except a0 and a1, all the coefficients I have substituted them as 0. So what is left with me? a0 x0 plus a1 x1 equals to y. So what is this is x0 is 1, so I'll get a0 plus a1 x is equal to y. So now if you look at this closely, what do you see? You see that the highest power of x, so this is known as my power. So the highest power of my x is 1, right? So in this equation, if someone tells me what is the highest power of x, I'll say 1. So any equation of this form in which the highest power is 1 is known as a straight line. Okay, let's suppose if I kept a2 as non-zero, so I would have got this equation. So a0 plus a1x plus a2x square equals to y. So what kind of equation is this? In this equation, the highest power of x is 2. So this equation will be a quadratic equation. Okay, so this is a straight line. This is a quadratic equation. This is a quadratic equation. Now if I had a3 as also non-zero, right, then the highest power would have been x cube. Then I would have got a 3-degree polynomial, right? So what kind of polynomial it is? It depends on the coefficients present here. So now I hope what is a straight line is clear to you. So if I want to write the general equation of my straight line, I will write a0 plus a1x is equal to y. So now let's write this in some manner which is familiar to me, right? So if I write this as y equals to mx plus c. So in your lower classes you might have heard about y equals to mx plus c, and that is the equation of a straight line. So if I compare here, this y is similar to this y, okay. A1 is basically my m because it is associated with x, and a0 is basically my c. So I can say a1 is my m, a0 is my c. So from now on, whenever I will talk about my straight line, I will talk about this. So this is my general equation of my straight line. Okay, they both are the same, right? We are just writing a1 as m and a0 as c. So this is the general equation of my straight line. Now let's talk about m and c, because I know that this is a function in which x is my input and y is my output. But what about m and c? So let's look at m and c. So first m. So m is known as slope. M is known as slope and c is known as y-intercept. So slope and y-intercept. So what are slope and y-intercept? So to get more information about this, let's try to look it by drawing the straight line. So to draw a straight line, right, in lower classes you would have used a scale to draw a line, right? You used to mark 2 points and you used to join them. So to make a straight line I only need 2 points. So let's make any 2 points. So one point I have taken this and other point I have taken this, and if I connect both of the points I will be able to make a straight line. So I have made a straight line. Now I have to calculate what is m and I should know what is c. So first let's talk about, so this is my general equation. So m is known as slope and y is c-intercept. So let's talk about slope and intercept, right? So slope and intercept. So let's jump here. Let's say this is my straight line. Now in this straight line, if I see, first what you have to do to find slope, okay, to find slope, first you look the point where it cuts the x-axis. So I will locate the point where it cuts the x-axis. This is the point where it cuts the x-axis. Now you draw a line along the positive x-axis. Always move towards your right. Always moves towards your right. So first step is locate the point where it cuts the x-axis. Second, you have to move towards your right. Okay, always towards positive x-axis. Second line you draw from that point along my straight line. So first thing is you locate the point where it cuts the x-axis, okay, and you have to draw two lines. One is along the positive x-axis and second is along the straight line. Now you move from your x-axis in an anti-clockwise manner. So this angle theta is the angle which the line makes with the x-axis, correct? So this is the line angle which my straight line is making with the x-axis. So what is slope? So slope is given as slope, basically my m is given as tangent of theta, tan theta. So what do you have to keep in mind? How we measure theta. This is very important, that we only measure the theta with positive x-axis. Okay, so keep this in mind. So this is my first way we can calculate slope. So let's do an example. So let's say if in this question I have a straight line and this is my straight line and this theta is equal to, let's say, 60 degree. So what will be the slope? So I can say the slope m is equal to tan of 60 degrees and tan of 60 degrees is √3. So this is my slope. So now you know what a slope is. Now let's talk about the y-intercept. So now in this question you know what m is, right? M is basically tan theta, tangent of theta, and you know how you can calculate theta. This is my theta. Now let's talk about C, that is my y-intercept. So what is y-intercept? So first, so now let's come back to the straight line. Let's come back to the straight line. Okay, so let's talk here. So first of all, to calculate slope, what did we do? We found where my straight line cuts the x-axis. Now I will find the place where my straight line cuts the y-axis. Okay, and I will locate my origin. So this distance is known as y-intercept. So to calculate intercept, y-intercept, what do? We first find the place where my straight line cuts my y-axis. Okay, and second I locate my origin. The distance between these 2 points is known as my y-intercept. Okay, so if this, let's say I have a question that if I have a straight line like this, and in this straight line, let's say this is line number 2, and in this straight line if I want to find my y-intercept, so what will I do? I will first locate the place where it cuts the y-axis. So this is the place where it cuts the y-axis, and second I will locate my origin, right? So for now let's say this is -3, right? So now the distance between the 2 points, right, you will say the distance is 3, but the intercept will be -3. So y-intercept is equal, this is my y-intercept. So keep in mind that we have to take intercept with sign. Okay, now let's move forward. So now we will talk about the different ways in which I can write my straight line. So first, this was the general equation, and in my general equation we found out what m is, what c is, right? M is my slope and c is my y-intercept. So let's write the general equation, slope-intercept form. So as you can see, what do I need to write the equation of a straight line? I need a slope. So slope is basically m is equal to tan of theta. And what is intercept? This intercept is basically my y-intercept. This is my y-intercept. So let's write. If I want to find the equation of my straight line, what do I need? I need slope and y-intercept. So we have already done this part, right? The general equation y equals to mx plus c, right? Y equals to mx plus c. Here m is my slope and c is my y-intercept. So this is basically my general form only. So let's do an example. So let's say I have a straight line like this, and it cuts the y-axis at 2, and let's say this theta is equal to 30 degree. So now if I want to write the equation of my straight line, I'll write y equals to m. So what is m? So first let's calculate theta. So first I will find the place where it cuts the x-axis. So this is the place where it cuts the x-axis. Then I'll draw a line along the positive x-axis. So I'll draw a line along the positive x-axis, and I'll draw a line along my straight line. So if I now move in an anti-clockwise sense from my x-axis towards the line, this angle is basically my theta, and theta is given to me as 30 degree. So what is slope? So slope m can be written as m is equal to tan of theta, that is tan of 30 degrees. So that is equal to 1 upon root 3, right? So y equals to m x plus, Now C is my y-intercept. So y-intercept is 2, right? So y-intercept is 2. So this is my equation of the straight line for the given question. So I hope it is clear how you can use this slope-intercept form. So let's do one more question. So find the slope and y-intercept of the equation given to me. So I have this equation 2x minus y plus 5 equal to 0. Now in this equation, I want to find the slope and the y-intercept. So first I will try to write it in the form of y equals to m x plus c, right? So if I want to write this equation in y equals to mx plus form c, I'll take y equals to, I'll take y that side and I'll get 2x plus 5. Now if I compare both the equations, the equation given to me in the question and my general equation, so from that I can see that m is equal to 2 and c is equal to 5, right? So what can I say? That my slope m is equal to 2 and my y-intercept is equal to 5. So c is equal to 5. I hope this question is clear to you. Now let's move on to the next question. With the slope 6 and y-intercept 4, find the equation of a straight line. So in the question it is given that slope is equal to 6 and y-intercept is equal to 4. So m is equal to 6 and y is equal to 4. So c is equal to 4, that is my y-intercept. So which form I can use? I can use slope-intercept form, right? I can use slope-intercept form. So I can use y equals to m x plus c. So y is equal to 6x plus 4. So this is the equation of my straight line. Okay, so I hope you are getting how you can use slope-intercept form to find the equation of a straight line. So with that, let's move on to next form, that is slope point form. So as the name suggests, what do I need? I need a slope, that is m, and I need a point. So which point they are talking about? So let's discuss that. So let's say I have this straight line, and on this straight line, just try to think how many number of points can be there on this straight line. So can you say, can I say that there can be infinite number of points on the straight line? Because this is going from this point to this point, okay, very far away. So let's take any point. So let's take this point. So this point is lying on the straight line, right? And this x, this is basically my x coordinate, and this is basically my y coordinate. So if I want to write the coordinates of this point, this will be x comma y, right? Remember the x is negative here, okay? So let's take it minus x, this is minus x, right? So this is the location of point P. So basically they are talking about any point P which lies on the straight line. So let's say that point P is equal to x0, y0, okay, any point x0, y0 which is lying on my straight line, right? So I can say this point lies on the straight line. So let's write the equation. So now if I write my general equation, I'll get y equals to m x plus c. Now m is not an unknown, m is already given to me in the question. But what about c? C is not given to me in the question. Instead a point P x0, y0 is given to me in the question. So since this point P lies on my straight line, right, that point will satisfy my straight line. That means it will lie on my straight line. So let's substitute. So for input x0, the output I'll get is y0, right? That is what a function means, that for my input x0 I'll get an output of y0. So for an input of x0 I'll get an output of y0 in this equation. So I get C as y0 minus m into x0. So now I have my C also. So now what I'll do, I'll substitute this C back in my general equation. So what do I get? I get y equals to m x plus the C is y0 minus m x0. So in this equation now I know everything, right? So in this way you can find the equation of a straight line. So slope point form, where x0 and y0 are my points and m is the slope. So in this we know each and every term. Let's move forward. So let's do one question. Write the equation of the line in a slope-intercept form where the slope is -2 and passes through the point 0, 9. So they are saying that we want an equation of the form y equals to mx plus c, right? Because that is what a slope-intercept form means. So let's make a straight line first. So this is my straight line. Okay, let's make some other straight line. Let's make any straight line. And it is given to me that this equation, this point passes through 0, 9. So 0, 9 will lie here, right? So this is 0, 9. And slope m is given as -2. So m is given as -2. So now to solve this equation, first I'll write my general equation. That is y equals to m x plus c. So now I know what m is, so I'll substitute the value of m. So y equals to -2x plus c. So here I do not know c, what c is. So just substitute the point 0, 9. So 9, so what is the value of x? X is basically 0. Corresponding to that, y is equal to 9 plus c. So if I solve this, I'll get 9 is equal to c. So if I want to write the equation now, equation will be y equals to m x plus c. So this is my equation of the straight line, and this is in a slope-intercept form. That is my general equation. So let's do one more question. Write the equation of the line that makes an angle 60 degree with the positive y-axis and passes through 1, 3. So let's draw the diagram. So this is my coordinate axis. Now in this I have a straight line which makes an angle 60 degree with the positive y-axis and passes through 1, 3. So let's say I made any random straight line and it makes an angle 60 degree with the positive y-axis. So this is my straight line and this is my positive y-axis. So this angle is given to me as 60 degree and it passes through 1, 3. So let's take point P 1, 3 here. Let's say this is 1, 3, right? So now in this equation, if I write y equals to mx plus c, now neither m is given to me nor c is given to me, but some angle is given to me and some point P is given to me. So let's first find slope. So to first find slope, what I'll do, I'll find the place where my straight line cuts my x-axis. So this is the point where my straight line cuts my x-axis. Now I draw a line along my positive x-axis, and the other line I draw along my straight line. This angle is theta and slope is equal to tan of theta. So I need this theta basically. So let's try to find this theta. So as I can see here, if this angle is 60, can I say this angle will also be 60? Right? So if this angle is 60 and I know this angle is 90 because my coordinate axes are inclined at 90 degree to each other. So this is 90, this is 60, and sum of all the angles of a triangle are 180. So 90, 60, this should be 30. And if this is 30, this angle comes out to be 120 degree because the total angle will be 180 degree. So if this is 30, sorry, this comes out to be 150. Apologize. This angle comes out to be 150 because the total angle is 180 degree. Right? So this angle is 150 degree. So what is slope? Slope m is equal to tan of 150 degree. So now tan of 150 degree, how to calculate tan of 150 degree? So those of you who know, we can write this as tan of 180 minus 30. Right? And since 150 lies, tan 150 will lie in my second quadrant. This will basically be negative, right? This will be negative, and since this is a horizontal angle, tan remains tan. So I can write tan of 30. So this will give me minus 1 by root 3. Some of you might be wondering that what we have done here, right? So this I will be going to cover in trigonometry. Okay, so the next topic is trigonometry, so I will be covering in that class. So if you don't know, please wait. If you know, very good. So let's move forward. So now I know what the slope is. So I know the slope m is equal to minus 1 by 3, and I have a point 1, 3. So I know that this point will satisfy my straight line. So let's substitute that point in my straight line. So what do I get? I get y equals to m x plus c. What is the value of x? X is 1 and y is 3. So x is 1, corresponding to that y is equal to 3. So what do I get c as? I get c as 3 plus 1 by root 3. So now I'll substitute this c in my general equation. So what is the answer I get? I get y equals to m, that is 1 by root 3 x plus what is c? C is 3 plus 1 by root 3. So I hope this is clear to you that how we calculate this. Okay, so what are the concept I use? The concept I use that how to find this slope, and the second is slope point form. Okay, so let's move on to the next question. 2-point form. So now 2-point form, this is the third form of my straight line. So in a 2-point form, as the name suggests, I need 2 points, right? So let's say I have some point P x1 y1. This is some point P x1 y1 and some point Q x2 y2. Now if I want to find the equation of a straight line, so let's first remove this. Let's take the point here. So let's go back to this point. Okay, let's go back here. Okay, so now if I want to find the slope here, right, if I want to find the slope here, I have 2 points P and Q. So I will make a similar diagram here. So let's make a diagram here. So let's say I have some point P x1 y1 and Q x2 y2. Now let's join both the points. Let's join both the points. Now this point P has coordinates x1 y1. So I can say this distance is x1 and this distance is y1. Similarly, this point Q has this as y2 and this distance is x2, right? Now I want to find the slope. So now to find the slope, we use the equation m is equal to y2 minus y1 upon x2 minus x1, or if I take minus sign common, what do I get? y1 minus y2 upon x1 minus x2. So now how to get this? So let's look here. Okay, now to find the slope, I know what is the slope. Slope is equal to tan theta. Slope is equal to tan theta. So let's make some, I'll just remove this and make some other diagram so I can make you understand. So how to get this slope. So let's first make a straight line and I'll take 2 points on my straight line. So let's take point P x1 y1 and some point Q x2 y2. Now for this point, this length and this length, so this length is basically equal to x2 and this length is equal to y2. Similarly, this length is equal to x1 and this length is equal to y1. Now let's see. Yeah. So look here, if I want to find the slope, I'll find the point where it cuts the x-axis. I'll draw a line towards my x-axis and along the straight line. So this, if I move in an anti-clockwise direction, this theta is basically the angle which my straight line makes with the x-axis. So if you look closely here, can I say that, just let me remove this. So if I look here, if I see here, can I say that if this is theta, this angle will also be theta? Yes. So basically I want to calculate this theta, and in this triangle, can I say theta, tan of theta will be equal to perpendicular upon base. So what is this perpendicular? This is basically my perpendicular. So let's calculate this perpendicular. So this length I have already calculated. This length is basically my y1 minus y2, right? Because this is y2. So this length is basically y1 minus y2. Similarly, this length is basically my x2 minus x1, right? Because this is x1 minus x2. So I can write x1 minus x2. So what can I get tan theta is perpendicular upon base. So perpendicular is y1 minus y2 upon x1 minus x2, right? So if you are not clear with this diagram, please refer to this diagram. It will be easy for you. Okay, in this diagram you can see that this diagram is like this. Okay, so it will be difficult for you to understand, but try to understand this is y1 minus y2 and this is x1 minus y2. So the same thing I have written here, right? The same thing I have done here. Okay. So I know what slope is now. So basically I know that tan theta is equal to slope. So from this we can say that m is my slope, right? So this is another formula of how you can calculate slope. So now let's write my general equation. So general equation is y minus y1 equals to m x minus x1. And how to calculate m? We already found. Or I can use y minus y2 equals to m x minus x2. So this is the way, if 2 points are given to me, we can find the equation of my straight line. So let's try to find out. Let's try to solve a question. Write the equation of the line that passes through 2, 2 and 4, 4. So let's say a point P is given to me, that is 2, 2, and some other point Q is given to me, that is 4, 4, right? And this line passes through this is given to me. So what is the formula? Y minus y1 equals to m x minus x1. So let's say if this is x1, this will be y1. If this is x2, this will be y2. You can also do the vice versa. So let's find the slope first. So what is m? M is difference of y coordinate upon difference of x coordinate So difference of y coordinate, that is y1 minus y2, that is y1 minus y2 upon x1 minus x2. So I can write 2 minus 4 upon 2 minus 4. So that will give me minus 2 upon minus 2, right? And that is equal to 1. So I have slope equal to 1. So I can write y minus, what is y1? y1 is equal to 2 equals to, what is m? m is equal to 1 into x minus x1, that is 2. So I get y minus 2 equals to x minus 2. So this minus 2 cancels, so I get y equals to x. So this is my equation of the straight line. They have also asked me that does this line pass through origin? So for input x0, my output should be x0 because origin is 0, 0. If my origin lies on this line, right, 0, 0 lies on this line, it should satisfy this straight line. So for input x, that is 0, I should get output y equals to 0. So if I put input x equals to 0, what do I get? Y is equals to 0, right? So yes, this straight line passes through origin. So I can say yes. I hope it is clear how you can use 2-point form. Let's do one more question. Write the equation of the line that passes through x-axis at x equals to 3. So let's say I have a equation of a straight line that passes through x, that cuts the x-axis at x equals to 3. So x equals to 3 and y-axis at y equals to 5. So y equals to 5, right? So if I want to write the equation of a straight line, what can I say? I can say that this point is basically 0, 5 and this point is basically 0, 3. So I have 2 points now and I'll join the point using a straight line. So let this point be x1, y1, let this point be x2, y2. So I think I have made a mistake here. This should be 3, 0. This should be 3, 0. Because x coordinate is 3 and y coordinate is equal to 0. So this is 3, 0. So that is equal to x2, y2. So if I want to write this equation, I can write y minus, now let's use the second equation, y minus y2 equals to m x minus x2. So I can write y minus, what is y2? y2 is 0 equals to m. m is y1 minus y2 upon x1 minus x2. So y1 minus y2 upon x1 minus x2 into x minus x2, that is 3. So what do I get? Y equals to minus 5 by 3 into x minus 3. So I get y equals to minus 5 by 3x, and if I multiply I'll get plus 5. So this is my equation of the straight line. I hope it is clear. Now the second part is, does this line pass through 2 comma 1? Now for input x equals to 2, I should get y as 1. So let's substitute y x equals to 2. So if I substitute x equals to 2, I get minus 5 by 3 into 2 plus 5. So I get minus 10 plus 15 by 3, that is 5 by 3. So for input x equals to 2, I am getting y equals to 5 by 3. I am not getting 1. So I can say that it does not pass through 2 comma 1. It passes through 2 comma 5 by 3. Let's move on to the next question, next part. So the final part is 2-intercept form. And in 2-intercept form, as the name suggests, 2-intercept will be given to me. So now I know what is one intercept. One intercept is y-axis. So let's say I have this equation. So I know this is my y-intercept. This is my y-intercept. And this will be equal to my x-intercept. So if I have, let's say my x-intercept is equal to a, and let's say my y-intercept is equal to b. So if I have a line in this form, I can write the equation of a straight line as x by a plus y by b equals to 1. And you can also prove that. Okay, so I give you this as a homework, okay, as an exercise for you to prove that how you can get this form. Okay, I'll give you a hint. You already know what C is, right? You already know what C is. C is basically B, right? And to find the slope, you need tan theta. You need this theta, right? But what angle you have? This angle you have. That is basically this theta, that is B by A. So with that information, you try to solve this. Or you can also solve using 2-point form, because this passes through 0 comma B and 0 A comma 0. You can also use 2-point form. So this is 2-intercept form. Now let's do a question. Write the equation of a line that passes through x-axis at x equals to 3 and y equals to 5. So this is the same question we did right now, right? This is the same equation. So let's solve using 2-intercept form. So basically this is equal to 5 and this length is equal to 3, because if it cuts the x-axis at 3, this length will be equal to 3. It cuts the y-axis at 5, this length will be equal to 5. So I can write x by a, that is 3, plus y by b equals to 1. So let's try to solve this. So I'll get y by 5 equals to minus x by 3 plus 1. So what do I get? Y equals to minus 5 by 3x plus 5, right? So look here, y equals to minus 5 by 3x plus 5. We can directly get the answer. Does it pass through the point 2 comma 1? No, it does not. It passes through 2 comma 5 by 3, as we have already calculated. So this is how you can leverage 2-point form. Now these were the 4 ways in which you can write the equation of a straight line. So if I want to summarize, the first form was slope-intercept form, that is y equals to mx plus c, where m is my slope and c is my y-intercept. The second form was slope point form, where I need a slope and I need a point. That point P is basically a point which lies on my straight line. So that point will basically satisfy the straight line. So just put that point in the straight line and you get C. The third form was 2-point form. So in 2-point form, 2 points are given to me which lie on the straight line. So in 2-point form, the equation which we use is y minus y1 equals to mx minus x1 or y minus y2 equals mx minus x2. And to calculate m, we use the formula difference of y coordinate upon difference of x coordinate. My last form and the fourth form was 2-intercept form. And in 2-intercept form, I have two intercepts, that is x-intercept and y-intercept. So if x-intercept is equal to a and y-intercept is equal to b, I can write x by a plus y by b equals to 1. Now let's talk about parallel lines. So what do you mean by parallel lines? When I say parallel lines, so let's say this is line 1 and this is line 2. So when are two lines parallel? Two lines are parallel when distance between 2 points on the line, let's say this is point 1 and this is point 2, and the perpendicular distance between the points, that is always constant. This distance is always constant, and in that case we say that the two lines are parallel. So if we look closely, let's make the diagram on the coordinate plane. So if two lines are parallel, can I say that this angle theta and this angle theta will be same? Because if I try to merge both the lines, let's say if I merge both the lines, if I shift them parallel to itself, right, I will get one line and I can see that that line makes angle theta with the x-axis. So any number of lines which are parallel to or line L2, L3, all these are parallel. So they will, each of them will make equal angle with my x-axis. So if angle is equal, can I say slope is equal to tan theta, right? So slope will be equal for parallel lines. So parallel lines, slope is equal to, slope are equal. This is the condition for two lines to be parallel. Now, so let's do one question. Write down the equation of a line that is parallel to x minus y equals to 2 and passes through 2, 3. So I have a line that is x minus y equals to 2. So I can write this as y equals to x minus 2. For this, the slope is equal to 1 and c is equal to minus 2. I want to write down the equation of a line that is parallel to this line. So if I have another line that is parallel to this line, right, this line was my y equals to x minus 2. I have to write a different line that is parallel to this line and it passes through 2, 3. So if this has slope m equals to 1, this will also have slope m equals to 1. Now I want to write the equation of a line that has slope m equals to 1 and it passes through 2, 3. So which form I will use? I will use slope point form. So let's write y equals to mx plus c, y equals to x plus c, y is 3 when x is equal to 2 plus c. So I get c equals to 1. So the equation of the straight line is y equals to x plus 1. This is the answer. And this line is parallel to this line and passing through 2, 3. I hope it is clear to you. Now let's move on to the last part, that is perpendicular lines. So perpendicular lines mean one line and my other line. So L1 and L2. So two lines are called perpendicular when the angle between them is 90 degree. So let's find the condition. So let's say I have line 1. So let's say I have this line, and this line makes an angle theta with the x axis. I have one more line that is perpendicular to this line. So this will make an angle of 90 degree with my first line. So if this is 90, can I say that it makes an angle of 90 plus theta with the x axis? Because if this is making theta, this is making 90 with my first line. So 90 plus theta is my total angle. So the slope for my first line m1, let this be line 1 and this be line 2. So m1 is equal to tan of theta, and m2 is equal to tan of 90 plus theta. And what is tan of 90 plus theta? Tan of 90 plus theta is cot minus of cot theta. Those of you who don't know what is tan 90 plus theta, please wait, okay? In the next class, when we talk about trigonometry, I will cover this. So now I know I can write that m2 is equal to minus 1 upon tan theta, and minus 1 upon tan theta is minus 1 upon m1. So from this I can get m2 is equal to minus 1 upon m1. So I can get m1 into m2 is equal to minus 1. So this is the condition for two lines to be parallel. So I can say two lines are parallel when the product of the slope m1 into m2 is minus 1. I hope it is clear to you. So let's do a question regarding this. So first question is, write down the equation of the line that is perpendicular to 2x minus y equals to 1 and passes through 0, 9. So I want to write the equation of a line that is perpendicular to this line. So let's say this line is 3x minus y equals to 1 and passes through 0, 9. This angle is 90. So what is this equation? This equation is y equals to 3x minus 1. So the slope m1 is equal to 3. For this, let the slope be m2. So I know m1 into m2 is equal to minus 1. m1 is given to be 3 and m2 I have to find is equal to minus 1. So m2 will be equal to minus 1 by 3. So now the slope for this equation is minus 1 by 3 and it passes through 0, 1. So y equals to m x plus c. I can write y is basically 9 when I get input of 0 when x equals to 0 plus c. So I get c as equal to 9. So just substitute the value of c back to my equation. What do I get? Y equals to m x plus c. So this is the equation of my straight line. So I hope this question is also clear to you. So I give this question to you as an homework. Okay, in this question, in the straight line passes through point 5, minus 2 and point 11, 1. So I have a point A and I have a point B, and I can draw a line using this. So you can write the equation of A and B using 2-point form, right? So I want to find the equation of a line perpendicular to line AB and passing through the origin. So draw one more line that is perpendicular to this and passing through 0, 0. So please try to find this equation. I hope it is clear. So we'll be meeting in the next session. Till then, thank you. And also this is the link QR code in which I have attached some questions. Please scan this QR code so that you can solve the worksheet which has been attached with it. So I hope you enjoyed the session on straight lines, and I hope it was informative. Please do like and subscribe the channel, and keep on following for more such videos. Thank you.